Okay, so I'm going to see if I can explain what I was doing here. Let me zoom in here so that what I'm saying here makes sense. So this is number 47. Here's our function here. So what we're going to do is we're going to let y here equal this. So what that lets us do is it lets us set up a balanced equation. So that's what I did here. Put a y here, and then we're of course going to take our limit of that. So then what we're going to do is we're going to take the natural log of both sides here. That's where I'm at. So we're doing the natural log of y here and the natural log of this friggin' mess. Okay, and then what we're going to do is we're going to use the properties of exponents. Properties of exponents allow us to take this exponent and pull it in front of our logarithm. So that's what I did here. We have our n. I pulled this n here and put it in front, and then rewrote the whole mess. Let me rewrite my n. So we're doing the natural log of n times natural log of 1 plus 2n. Oh, and I goofed. There should be an n there. Oh, wait a minute. No, there shouldn't be an n because we moved it. Derp. So now, at this point, if we use substitution, we plug in infinity, we're going to get basically infinity, the n, we have this infinity here, times plugging in infinity for this is going to basically give us 0, so we have infinity times 0. That's not really something that we can utilize just yet. So what we're going to do, what I did now, is I basically rewrote this again so that we're taking the limits of both sides. Technically, this should have been up here in this step, but I'm kind of lazy. And then, so now we're going to take the limit of both sides. Now, what we can do that's really cool here is, see, we have two terms here. We can take those terms and we can invert them. We can invert one of them, rather. So I could either do 1 over n, or I could do the natural log of 1 plus 2 over n. What I decided to do was invert n. So what we're going to end up with is the natural log of 1 plus 2 over n all over 1 over n. And let me show you what that looks like. Scroll up. This right here. So, see, I took the n that was out here, put it as 1 over n, and put it down here. And the reason why this is really cool is because, so first of all, if you take this whole mess right here, well, actually I wrote it up there. If you take this and you rewrite it, you should get, come on, scroll, dang it, you should get this again, this stuff. So you can actually legitimately invert it, and it doesn't alter the original function. So if I took this n and I took this and multiplied by n over 1, I'm going to get n times this mess, and that'll, this will cancel with that. So so this is actually legitimate to do. But the cool thing with this is if I use substitution now, if I substitute, so we have 1 over n, well, if I make that infinity, well, 1 over a really big number equals 0. Well, let me see if I write as 0. Okay, and then this is also going to be 0, which gives us 0 over 0, meaning we can L'Hopital, we can use L'Hopital's rule on this stuff. So that's what I'm going to do. I'm not going to show the chain rule here because that would take too much time, but when you chain rule all of this, you're going to get this. This big whole mess. When you simplify it, you're going to end up with this. Okay, and you can, when you do substitution on that, you're going to get 2 times the really big number is infinity. Infinity plus 2 is infinity, so you're going to get infinity over infinity. Pardon my crappy, oh, you know what? I wrote it down here. Boom! You're going to get infinity over infinity, so we L'Hopital this again, so we take the derivative of that, we're going to get 2, take the derivative of that, we're going to get 1, and look at that, like magic, 2 over 1 shows up right here. Amazing. So now we've got 2. So what we're doing is the limit of the natural log of y as n approaches infinity equals the natural log of 2. What we want to do is we want to get rid of this natural log, specifically this one. We want to get rid of that. So the way we do that is we're gonna basically bump them up exponentially. So one of the interesting things is you may or may not remember this because I had to look this up. So if you know some of this, don't take this as me like talking down or anything. This was just stuff that I had to review because I've forgotten some of this. When you multiply both sides or whatever to try and get rid of the natural log, I don't know what you call that. When you're trying to cancel out the natural log, this 2 ends up becoming e to the 2. That's what ends up happening with it. So I don't know what you call this to it's like multiplying both sides by the natural log of whatever. When you're doing that, this 2 ends up becoming e to the 2. If this was a 3, then it would become e to the 3. So then what we end up with is this right here. The natural log, the limit of n as it approaches infinity of y equals e squared. And that's basically how you do that. It's pretty straightforward. The 2 things I'll bet you probably missed, because again I wasn't thinking about it, was this right here, the fact that you can invert one of these and make it 1 over n and stick it on the bottom of a fraction, and this part right here, where to get rid of the natural log you'd have to bump that 2 to the e to the 2. So anyway, I hope that helps. I'm going to upload this to YouTube, and yeah, my rambling. There you go. I'll see you Monday in class.